Good afternoon, pilot teachers and students, and good afternoon, model class.
Good afternoon, Mr. Simon.
Okay, thank you very much. You may sit down. All right, our topic for today is appearing on the screen there, and that is on gears and pulley. All right, as you can see, if we were we have been going through topics on machines, and we studied on mechanical advantage as well as the velocity ratio. Now, as you can see from our topic, if you want to calculate or if you want to find out the velocity ratio and also the mechanical advantage, or let's say the velocity ratio, that is simply for gears, we can find out or calculate that using the pulley or the driven wheel and also the wheel that is driven, a driving wheel and a driven wheel. And on pulleys, if you still want to find out the velocity ratio, that is by working out the number of the ropes that are used on the pulleys. Right, that will give us the velocity ratio. Now, before I go on to giving you some information on these pulleys and also the gears, I will explain to you how you can find the velocity ratio on inclined plane. All right, if we have an inclined plane like this, and let's say you are pushing a cart up this plane, velocity ratio is simply, okay, not V, that should be VR, equals to distance of the, right, that is distance up the plane divided by the distance along the plane. All right, that is especially finding out the velocity ratio on a inclined plane. Right, you also saw in the other topics or learn from the other topics that if you want to find the velocity ratio, especially on levers, that is a distance between the length of the fulcrum, or let's say between the effort and also the load. Okay, we will now go on to have a look at some of the information on gears and pulley, and from that I will give you some diagrams to show you what gears are and pulleys are, and then from there will be some activity questions given to you. All right, you can start now. Okay, like the wheel and the axle, the gears are kind of continuous lever, and they can be used as a force magnifier or distance magnifier. Okay, moving on. Okay, especially on gears, you will find that very small wheel will have a less number of teeth. Right, especially if you become a mechanic, probably you might study the gear system and then see when a driver has to shift the gear from one position to the next. Right, it is a pinion gear that will go from one position to the next. When it goes to the largest of those gears, meaning that it has more teeth, then obviously the speed of the car will be quite less or small. Okay, those are the gears like the first gear and probably the second gear and so on. All right, if the pinion gear has to shift, let's say shift to the gear that has small number of, or let's say less number of teeth, right, the car would be moving more quickly. So that is especially for gears on a car, right? Every different types of machines will also have gears, especially in a factory or in a manufacturing plant. You find machines that will use these gears. Okay, let's move on. Okay, because it has less number of teeth, it will have to turn twice to turn the larger wheel once. All right, that is especially for the gears. Now, that small wheel is a driving wheel, and it will have to turn the larger one, which is a driven wheel. Right, let's move on. Right, this is how you can calculate the velocity ratio, the number of teeth on a driven wheel divided by the number of teeth on a driving wheel. So in this case, the driven wheel will be the larger one, and then the smaller one will be the driving wheel. Now, if you still consider the mechanical advantage, that is almost equal to 2, because you calculate the velocity ratio to be 2. we have finished, we will now move on. Right, this time we'll look at the pulley. A pulley is useful in lifting loads vertically. In fact, if you want to calculate the number of, let's say the velocity ratio, then you can use the number of pulleys or either the number of ropes that are used on a pulley. All right, just to show you some diagrams, especially if you don't know what gears are. In any machines, if you find something like that, that is a gear. Okay, you can find a number of teeth in there with a very big wheel and a small wheel. All right, that is especially another diagram showing you one of the teeth that has been fitting into the larger wheel. Right. Example of machines that will use gears are the motorcycle. Probably you will find okay, the driving wheel will be somewhere in there, and this will be driven by this driving wheel. So it is quite small and it is close to the engine. That is for the driving wheel. But for bicycles, you will find that at the back. Okay, that is where you will find the, or this one. Okay, this is where you will find the driving wheel. Because it will have to go once, and this one probably 3 times or 4 times, and that will move this wheel to go faster. All right, those are some importance of having gears on any one of these machines. All right, the gear that is almost closest to the pedal will have to move once, and then that will move either 2 or 3 times. So in other words, it will magnify this. All right, let's have a look at other diagrams, and then I will give you activity questions on gears and pulley. All right, that is your activity question. I'd like you to copy those questions, and then I'll give you some time to complete that activity question. All right, question number 1. Gear wheel has a gear wheel A with 20 teeth is used to drive a gear wheel B with 60 teeth. Okay, what is the velocity ratio? Okay, question number 1. I'll give you question B based on question number 1, and then there's also another question coming later. So quickly copy the question that is appearing on the screen. All right, question 2 now. Question 1B. Okay, you don't really need to count the number of teeth on that diagram there. All right, just read the questions and then you answer. But obviously the number of teeth is asking you to calculate the velocity ratio. On to question number 2. Right here is question number 2. I will give you the diagram. Okay, write that question first, and I will give you or show you the diagram. here is a diagram for that question. Right, how many pulley system can you see in there? All right, so by counting the number of pulleys, you can find the velocity ratio. Finish. Number one. Question 1, question 2, and question 3. Sorry, B will be you, and B will be you, and we'll see who will be the last. Which is Joe. You took question number, the last question, number 2. To question number 2, number 1. Number 1A. Okay. Okay. Question number 2, number 1B would be you. Okay, not you. And the last question, huh?
Number 1B.
Yeah. Okay. I will now ask those students to come out now. You show you're working out. Those other students who are serving will have to do corrections according to the questions given. So the first answer to, or rather first question, we will ask one student to come up. Okay, Jolene, you can do that question. And okay, Mama, you get ready. Okay, question number 1. Can you clean that before you clean it? Clean it. Do you need to explain? Okay, you can just send in and explain. Yeah, send in.
The velocity ratio is equal to the number of teeth on the driven wheel, which is equal to 60, over the number of teeth on the driving wheel, which is equal to 20. So 20 divided into 60 is equal to 3.
Okay, velocity ratio. The student has given us 3 as the velocity ratio. All right, if you have 3, that is correct. Okay, we're moving on to question number 1B. Okay, Maima. All right, you can explain there. You can stand up then and explain. Yeah.
As you can see, the velocity ratio is 3 and the rotation per second is 3. When you divide that, you get 1. So
Yeah.
the rotation is rotates once only.
So you mean wheel A if A rotates 3 times every second, how many times does wheel B rotate? And his answer was 1. Okay, so it will have to rotate once. Right, so once. Moving on to question number 2. Right, that is the question for what is it? Okay, I'll send him out shortly. After this, you can send this one. Explain your answer.
Before finding the efficiency of the pulley system, first we need to work out the velocity ratio, which is found by counting the number of pulleys in the diagram, and then find the mechanical energy advantage, by dividing the load by the effort, and then find the efficiency, which is mechanical energy over velocity ratio multiplied by 100, which is 66.67%.
Right, if we have this answer, okay, that is correct. Right, if you can check out with this answer on the screen there, should be 3 times, and that is question 1A. Question 1B will be, it will have to move once, and question number 2 is 66.67%, or it can be 66.2%. All right, so that is the answer to activity questions on pulleys and gears. All right, quickly to summarize on that, you can always use mechanical advantage and also the velocity ratio to calculate work out the efficiency of a machine. Efficiency is how well a machine can perform and how it can transform that force that you apply into something that is more useful. So if a machine is 100% efficient, probably that machine has no friction. But you will always find that machines must always have friction, and the amount of energy that is put in is always, or let's say it is more than the amount of energy that comes out of the machine. So in this lesson, we have learned about pulleys and also gears. That is part of the topic or major topic on machines. All right, in our next lesson, I'd like to mention the topic that we will be studying, and that is on velocity and speed. Okay, so you have studied already the displacement and distance, and we'll have a look at velocity and speed in our next lesson. So with that, our key phrase for this lesson, okay, the key phrase here is gears and pulleys. What you can say. Okay, good afternoon, pilot teachers and students, and good afternoon, class. Thank you very much. You may sit down.
Thank you.
Michael, you're going to see me.